Today we are going to build XT-IDE Universal BIOS from scratch. Basically, we will compile it and only select the modules that we want to have in our XT-IDE BIOS. I ran into a problem with one of my mechanical drives. At the moment, XT-IDE BIOS is initialized and looks for the drives. It powered down the hard drive. And looking through a few of the forum posts on Vogons, I got to know that this is most likely related to the power management module. So today I want to build the same version that I used in my previous video, with the only exception to not have the power management module in it. And for this, I have to go ahead and rebuild the entire XT-IDE BIOS myself. There is a instruction how to do this. I will try this the first time, so we are going to go through all of this together. I'll also have the link in the video description, so if you want to follow along, you can do that. I will most likely also provide the unconfigured version for 386 systems that have a single channel IDE controller on my website. There will be a small article and you will be able to download that binary file, and you just follow the second section of this video to configure it for your system before you flash it on one of the EEPROM chips. We are going to follow this documentation, and as you can see, there is a lot of information which we will not all cover, but we will cover the main parts. So the first thing I will do is I will go ahead and download all these applications that are necessary here. So Tortoise SVN, this is a version control system for software. And here we just download, this is the download link. We do have a 64-bit operating system. Next we need min.gw. So this is a C compiler, if I'm not mistaken, and we take 10.3, and I am taking, I think I will go with this one here. Then net wide assembler, this is required for compiling some of the binary code of the BIOS as well, so we'll take the last stable one. Okay, we are in Windows 32, and here is an installer, so we'll take this one. Okay, and UPX, I know this says optional, but there may be something we'll try later on and we need that. Download latest release, and we also need Windows 32-bit. And finally, Strawberry Pearl. I think this is the largest download. I just looked through the resources, and here we can see that this is like 200 megabytes. So yeah, we need this one as well. If you're wondering, I'm using the Windows Sandbox here. So this is basically a virtualized environment. If you don't want to have your system cluttered with development things, I need to have my system as clean as possible for cutting videos. Let's, in the meantime, create a folder on our C drive, XT-IDE. So we will work in this folder directly in C. This makes it a little bit easier later on to find our path. So how far is our download? Almost done. Okay, now here it is. Let's start with Tortoise. We just leave everything on default. We'll not configure anything that makes things more complicated than they should be. So now let's go to our project here. Now if you go to our context menu, you see Tortoise SVN. And now we can check out a repository. And the repository is this URL here. So let's take, if I click on this one, I'll just go to that path, I think. So we'll just take the full thing exactly as it is written here. Trunk, we go and just say okay, and now it will go and download all those sources that is in that repository, and that's it. Now we will install the free C++ compiler. So we go to one second. what is this one here? Is there still something downloading? Oh, keep. Keep anyway. Yes, please. Okay. Just try to go one by one. Okay, so we'll create. I want to stay with 32-bit. Okay, that's fine. We all keep the default values. This is what the documentation also suggests. Just install everything as default. Okay, we don't need the README. Now we install NASM. This is here. Install for this PC. Yes. Next, next, install. Done. And we got a shortcut here. The next one is UPX. This is the configurator. I guess we can build the configuration file. Make sure that UPX can be found in the path variable. Okay, so let's see how this looks like. Okay, so here we need to do a little bit something manual. We just call it simply UPX. And we move this also to drive C directly into the root directory. Okay. Now this one we need to add to our path variable. Now I need to go to, where is this? I need to go to system, I think. So where do I need? Advanced system settings. I guess this is it. Yes. Environment variables. This one we need. We can go to the system variables here. So you could use both of them. I'll use the system variables here. And I just add a new option which goes to seed UPX. And that's it. That's all we need to do. Done. Okay. So we installed UPX. And then finally we have to install Strawberry Pearl. So Strawberry Pearl is here. And again, just standard installation. Yeah, everything in the root directory. Oh. And then we can try to build our own version of the XT-IDE Universal BIOS by going to a specific folder and then just run a certain command. So this is the first thing we'll try that will verify that our environment is set up correctly. And then we will try to build the XT-IDE Universal BIOS without the power management module. Okay, no README. So now let's go to our sources that we downloaded. This is in the XT-IDE folder. And we have here the XT-IDE Universal BIOS folder, which is here. And now we should be able to just run this command. So what we need to do now is we need to open the shortcut that was created on our desktop. And this is here. There we go. And now we need to navigate to our XT-IDE folder. And we go to XT-IDE Universal BIOS. So here's our source code. Now what we need to do is we need to run this command. This should build the XT-IDE BIOS binary file. Okay, even though we got some errors here, maybe this is something related to the configuration file or whatsoever, but I can see that there are some files that have been created. Unfortunately, it's just the small version of the 386, so let me double check. Where did it go? To, what's the folder? Deleted everything from build. So where's the build folder? Here's the build folder. Okay, so we got the files here. We got some bin files, but not our 386 large. Okay, that's a little bit unfortunate because this is the one I wanted to use. Let's start over. Does it clear the folder? Let's get rid of the build directory and try again. Okay, so we need to create a build folder. Okay, now it builds it definitely from scratch and we do get some output. But we have a problem in some of the assembler files here, which doesn't help me right now. I don't know how to fix that. This is PS2. Maybe I can get rid of this one. Let's just continue, because PS2 seems to be a binary file that I may not use. I just want to use the IDE 386.bin. So let's continue in the documentation here. And the next thing you will see, there are a list of modules. And you see, for instance, a module power management. And this is the one, apparently, that is responsible for powering down my mechanical hard drive when I'm trying to boot. So this is something I want to get rid of. Then here we are talking about a configuration file that allows us to configure which modules are supposed to be included in the binary files. And you can see you have an XT, XT plus, AT386. So there's somewhere a make file. Here we go. So let's open this in Notepad++. We see exactly the same what is outlined here. And probably here on the bottom somewhere is our definition, what is going to be included in each of these binary files. Here we go. So common, large, menu. So this is all. So what I need to do now is I need to figure out which modules I want to include. Let's make this bigger here. Let's look for our power management here. Power management. Okay, so there's not much. It's in the defines common. Okay, so I guess this is part everywhere, the power management. And then on top of it comes the menu, the boot menu, some IDE advanced options. I don't know, you can read what each of these does here in this table. I want to have the large, but without the power management. So what I will do now is I'll create a custom configuration. So I'll take all of these and get rid of the power management module. So this one goes out. And then I will use a variable to include the large definition. So now this one should be everything that is defined here. And so we had, this is our definition. So we need also the define 386. It uses this. Okay, so here's the common. Okay, so we shouldn't include this twice. So that means we need to most likely include everything step by step. I think this is the safest way. I don't want to include anything twice. So we started with the common, that is fine. But we also need to include, so the 386 large starts with whatever is included here. I don't know if the order of these modules are important or not. That's why we need to start one by one. This defines AT uses defines common. So this is the first one. And then we go ahead and we include all of those after the common. And the common was all of this. So let's get rid of this, what I added here. This was not that simple. So we use this part here now. We already have the common. Now we need to use this. Then we went one up. Now we use all these. Let's add these two. So now we are at 386, but we were at the large. And then we are adding everything that is here for the large build. So this is all the menu, boot menu. And I think this is it. Okay, so I think these are all the modules except for this power management. And we have included everything manually now. That's why this line is so big. And size common, I will also have to update this. This is also written in the documentation. So we'll take also the 12 kilobytes. We just copied this over to the custom because we're building a custom BIOS. And I think this is it. So let's just double check. So if you want to, you can read up more on the documentation. I will skip this because all I want is I want to have a custom BIOS that we can try this on my system and see if the hard drive stops from powering down when it boots. So a custom build, we have to add these two options. So we have the defines custom. This is what we did. And also the BIOS size custom. So this one we leave as is. And then we just have to call this command. I hope this works and will not run into this issue that we have seen here. So let's clean out everything that is here to be sure that only that common BIOS that we are building right now is going to be built. So, okay, so what's the problem? Custom. I spent about half an hour trying to figure out which revision was responsible for that problem that I'm facing, but I don't want to bore you with it. In the end, I used the last revision that worked, which coincidentally was just one revision behind, and all I had to do was change the revision number, and then I could compile the BIOS. But obviously that doesn't make much sense, there is just a number in it. So I tried to figure out why this is happening. So let me just quickly go into that folder with the revision file. I'm now in the last version. Let's try this. So we're updating. So I'm on the last revision that is available for XT-IDE. And if we quickly look at what I have changed, you can see this is just our definition of the custom ROM and the size. Everything else is unchanged. So I haven't changed anything. But if I go now to our source code and I go to INC, so this is our revision file. Let me open Notepad++. So this is our file. And then I was thinking, okay, so we get an error in main.asm. So I went to source main.asm and it was line 77. I just looked through it to see if there is something what could point us to the problem. And I saw this one here. So there are some includes happening, including the version INC. And I was like, okay, that sounds like maybe this is something we can look at. So the version INC is here. And then I just scrolled down and looked for revision INC and it's here. And then this comment here pointed me to what I could have done to just fix this issue. You see, this file must include a trailing space. So I went back to our revision inc and we can see there are two lines. Maybe this is the problem. So let's see what happens when I check out the previous revision. Let me go back to our root directory and we say we want to check out revision 628, I believe. Yes, this one. This revision worked. So let's just check out this revision. Okay, now we are at revision 628. I want to reload. So, and as you can see, revision 625 doesn't have a second line. So this is a problem in the source code. So yeah, this wasted a lot of my time just because there was a second line in the revision inc in the source code. This is not something that I caused. So let's just update to the latest one, the 629. Okay, so here we go. No, it was INC revision. You see, it has a second line. Now, if I try to build a custom, it doesn't work. If I go and remove this line, ta-da. Okay, I hope somebody sees this from the XT-IDE project. Please get rid of the second line. Well, we got our 629 build. This is the file that we need. And now we can continue from here. So I will copy this now and we will continue with the BIOS on the computer. We need to configure it because this is a BIOS that we cannot burn directly to one of our EEPROM chips. So after all this mess with trying to compile this BIOS, we are finally on our machine. Now I need to configure it first. So I need to use our 500 megabyte drive. This is the compact flash drive. And I think, yes, all of this is okay. We need to configure the BIOS because we need to make sure that the checksum and everything is set up correctly based on our system. This was the problem that I had in my first video. So let's quickly do that. I think I have everything in here. Oops. So yes, and here you can see the IDE underscore CSTM. This is our custom build. And we have the XT-IDE CFG that we need to run first. So XT-IDE CFG. And now we can load the BIOS from file. And I want the custom file. And you see this is a lot smaller now here. Successfully loaded. That's good. Configure. So here again, we have the two primary and secondary IDE controller. So we have two. I only have one. This needs to be fixed. And as you can see, I think there was a power management section here in the old BIOS, in the one that I downloaded from the pre-built versions that were available on the XT-IDE website. So we leave everything as default, but I will run the auto configure and it reduces my IDE controllers from 2 to 1, and maybe it does some other things there as well. The rest should be as it was before. So we have device type. This I think was all unchanged. And I don't see anywhere the power management. Let me save this back to the original file. So when I make this post on my website, you will have both versions. You have the one that you have to configure using that tool. So you will get that tool plus the unmodified BIOS file, or you can download the one that I'm creating here right now. So save BIOS back to the original file. And this we can save now to our EEPROM chip. We have the custom, which was changed at 2:30, which is my timestamp right now, so this is correct. Now I will write this file to an EEPROM, put it into my network card, and then we will see if the hard drive will continue to spin down after it was detected by XT-IDE. Okay, and here comes the moment of truth. I have the mechanical hard drive back at the system. Okay, hard drive spinned up. We need to get rid of our BIOS settings here. Let XT-IDE take over, and hopefully that will work. So let's hear if the hard drive spins down or not. Let's try. No. We built our own XT-IDE BIOS with the modules that we need. It should have all the modules except for the power management module. And now the hard drive just stayed running. Great. I'm very happy that I have this file now on this EEPROM. It does exactly what I need for all those motherboards that have no built-in IDE controller and have an I/O controller card with only one IDE channel. I want to finish this video with replacing this network card that doesn't have any jumpers on it with a network card that does have jumpers. So here on this card, we can set the IRQ, we can set the I/O base address, And we can set the memory location where the boot ROM will appear in memory. So let's just move this EEPROM to the other card. Make sure the orientation is okay, the notch to the notch. Okay. And now our network card has the EEPROM installed. And now we need to figure out how to configure these jumpers. I want to reconfigure this card exactly like the other card. And if I'm not mistaken, we had an IRQ 2 and 9. What I understood here is that this is a remapping, that IRQ 9 is remapped to IRQ 2. I don't know exactly why this is, but this is what these jumpers are used for. And then the base address was 300. And the memory location was set to C800. So now we need to figure out how to set these jumpers. And for this, unfortunately, you do need a documentation. I did find a configuration document on the RetroWeb for my card, which is the GE2003-2, I guess. And if you scroll down a little bit, we see the start of the jumper configuration. So this is JP1. Let's go to our card and have a look what JP1 is. So yes, this is JP1, the single pin header here. We need to close this pin header. This was open before. I want to fully configure this card with the jumpers. So let's close this pin header. Done. Now let's look at the IRQ. I want 2 and 9 as we had with the other card. And you can see that there is something already, I guess this means default values or maybe recommended values, 2, 9. This is what we had before. So we should have the next section open, open, open. And we have open, open, closed. So let's move this jumper to open. Okay, now we should have IRQ 2/9. Now let's go to our IO base address. We have, I think these are 4 jumpers for this section. So let's have a look. This is for the boot ROM. Here's the base IO address, and we want to go for 300. It again has the symbol here, so we want to go for open, open, open. Okay, and I think this is already on our card configured like this. Yes, so this is only a double pin header, and you can see that this is just hanging on here. So this is fine. This is already on address 300. And let's go to our boot ROM now. We want to go to C800. And this is here. So we have 5 pin headers to configure. And it is open, closed, open, open, closed. And we need to change this pin header, the last one. This one should be closed. And the next one still is open. And this one here should be closed as well. Okay. So I think this is the right configuration. Now this card should be configured exactly as the other card, and it should just work when we plug this card in. We are booting, and I'm expecting, yes, XT-IDE shows up, and it also detected our hard drive. So once you have configured XT-IDE, it looks like it will just work. At least I hope that this is what it is. Yes, we had some hiccups here and there, and I did not go through the entire documentation. But yeah, so read the documentation if you want to get more details and most likely learn a lot more than what I'm showing here. This was just me trying to wrap my head around XT-IDE. It took a little bit of time to get this done, but now I'm really happy that I have one copy of XT-IDE that seems to be working on my old retro systems. So let's just now boot from this drive, and yes, it boots. The drive doesn't power down, so that custom build without the power management module seems to be working great. I really don't care about power management for those old drives because I'm not going to use these systems on a day-to-day basis. I'm using them only for a project and then they go back in storage. So that solution is perfect for me. You may want to have the power management feature, but yeah, this is then up to you. If you found this video helpful, even though you saw me struggle with compiling this BIOS, then please consider giving this video a like, leave a comment, and if you want to support my work, then you can always go over to Patreon and select one of the memberships or sign up for free, where I post from time to time free content. And this is it for today. Thank you so much for your time, thanks for watching, and I will see you in one of my other videos. Take care and bye bye.